In this video, we'll cover a process for calculating the inverse of a matrix. And it turns out there's a simple procedure to follow with 3 steps. First, we form what we call an augmented matrix. So you start with the matrix A, and you make a bigger matrix out of that by putting A on the left side and an identity matrix of the same size on the right side, and forming a big matrix out of that. So if A was originally 3 by 3, your new matrix will be 3 by 6. Then you perform Gauss-Jordan elimination. And you keep going until you have an identity on the left side. And at that point, the right half of your big augmented matrix, after performing elimination, will be the inverse you're looking for. So let's look at an example here. Let's start with this 2 by 2 matrix A with entries 2, 3, 1, 2. We start by forming the augmented matrix. So this is shorthand notation for a matrix where you have A on the left side and an identity on the right side. And this is what it means. The first 2 columns are the columns of A. The second 2 columns are the columns of I. Now we're going to perform elimination. And so in order to do that, I'm going to subtract half of row 1 from row 2. That allows me to get a 0 in this second row first column entry. My next goal is to make this entry into a 1, so I'll multiply row 2 by the number 2. My next goal would be to make the entry above that 1 into a 0, so I'll subtract 3 times row 2 from row 1. And from that point, my next goal would be to make this 2 in the top left corner into a 1. So I can do that if I divide row 1 by the number 2. At this point, we have an identity matrix in the first 2 columns, and that means the second 2 columns are the inverse matrix. 2, -3, -1, 2. That's it. That's the whole process. Let's look at another example with a bigger matrix. So we'll find the inverse of a 3 by 3 matrix. Here's the matrix C. So I start by forming the augmented matrix with C on the left side and an identity on the right side. And then I want to perform elimination, and to make this 2 into a 0, I can subtract row 1 from row 2. Then to make this 6 into a 0, I can subtract 3 times row 1 from row 3. From that point, I want to make this 2 in the bottom row second column into a 0, so I can subtract 2 times row 2 from row 3 to achieve that. Now I've got a 2 in the bottom row third column. I want to make that into a 1. So I'll divide the last row by the number 2. From that point, I want to make a 0 above the 1 we just made. So I can subtract row 3 from row 2 to achieve that. I also want to make zeros, so above the 1 in the second row, I can subtract row 2 from row 1 to achieve that. And from that point, to make this 1 in the first row third column into a 0, I can subtract row 3 from row 1. We're almost at an identity matrix. The only thing we have to do to get an identity matrix in our left side is to change this 2 into a 1. So I can divide the first row by the number 2. So now in this matrix, we can see our identity matrix on the left half, and that means the right half is the inverse we were looking for. That's it. That's the entire process. Now, we went through the slides faster than you'd be able to go through this process by hand, because I wasn't going through all the calculations at each step to come up with the entries, but it's just Gauss-Jordan elimination, subtracting a multiple of a row from another row, or multiplying a row by a number.